Hey guys, welcome to Pre-Calc Lesson 3.7, Polynomial Theorems. Before we get to those theorems, let's do a little review from earlier in the unit and actually back to Algebra 1. This first example, I want you to solve using the quadratic formula. The quadratic formula has been given to you in Algebra 1 all the way through Algebra 2, but you have to have it memorized for this course. The formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. It's not necessary that you write this out, but I'm just going to remind you guys where a, b, and c come from. A is the coefficient of the squared term, so that's 1. B is the coefficient of the x term, negative 4. And c is the constant at the end, 1. So plugging into this formula, I get x equals the opposite of b, so 4 plus or minus square root. B squared, do that in your head, it's going to be 16 minus 4 times a, which is 1, times c, which is 1, all over 2 times a. Now, if I simplify this, I get 4 plus or minus square root 12 all over 2. And remember how we simplify this radical. I'm going to break that up to square root 4 and square root 3, and the square root 4 is just 2. So 2 square root 3 is going to replace that. That gives me 4 plus or minus 2 square root 3 all over 2. Now, remember how we simplify. You have to simplify all 3 of these. You can't just pick 2 of them because these are bonded together. So you got to divide all 3 by the same factor. In this case, it's going to be a 2. So that becomes a 1, that becomes a 1, that becomes a 2. So your final answer is going to be 2 plus or minus square root 3. Now, if you wanted to, you could also split those up. You don't have to in this case, but you could say x equals 2 plus square root 3, x equals 2 minus square root 3. And remember what we call these. Those are called conjugate pairs. All right, something you're going to want to know for this course. Next, is x plus 4 a factor of 2x cubed minus 4x squared minus 3x plus 2? Why or why not? Remember, we're going to use synthetic division for this. Since the root is a negative 4, that's what's going to go in our box. Next, I use the coefficients, a 2, a negative 4, a negative 3, and a 2. 2, negative 4, negative 3, and a 2. Remember, the process is really easy. You bring down, you multiply, you add, you multiply, you add, you multiply, and you add. So now, there's the synthetic division. It's going to be the same tool we use throughout the whole unit. But how do we answer the question? What do we use in this process to answer this question? Is it a factor? So I need a yes or no. I'm going to look here. That does not equal 0. So the answer is no, because the remainder does not equal 0. Our third problem. It says x minus 1 is a factor of x cubed minus 10x squared plus 27x minus 18. What are the other factors? The quickest way to do this is to use synthetic division to get our depressed polynomial. So 1's going to go in the box. My coefficients are going to be 1, negative 10, 27, negative 18. Here's the process. Bring down, multiply, add, multiply, add, multiply. Now I'm expecting 0 here because it says it is a factor, so that's good. Now, what are the other factors? Well, remember, these numbers here represent the coefficients of our depressed polynomial. The reason we call it depressed is because we start with a cubic and we divide off an x. So what that gives us is a quadratic, x squared minus 9x plus 18. There's my depressed polynomial. So let's jot that down. X squared minus 9x plus 18. So if it asks for what are the other factors, well, now I just need to factor this. All right, so I'm going to get x and x. Signs are the same, both negative. Multiply to 18, subtract to a 9, or combine to a 9, I should say. It's going to be 6 and 3. There are the other factors. All right, let's dive into some theorems here. First one is called the number of roots theorem. And what this says is, given p of x, which is just a polynomial, of degree n, and that is simply the largest exponent, there are exactly n roots. So it's a fourth degree, there's 4 roots. Fifth degree, there's 5 roots. Now notice, it just says roots. It doesn't specify what type. There are at most n real roots. So there could be less. If it's a fifth degree, you could only have 3 real roots, 1 real root, or you could have 5 real roots. But you can also have imaginary roots. So that's what this theorem says. There will be exactly n roots, but not all of them will be real necessarily. The integral root theorem. So what this says is, given p of x with constant, which if it's in standard order, it's just the last term, term c, the only possible integer roots of p of x are plus or minus factors of c. So that number on the end, that c term, the constant, let's say it's 8. What it says is the only possible integer roots have to be factors of 8. So 1 and 8, 2 and 4. That's it. The other thing here, it's kind of interesting, and that's why I put in this thought bubble. If a function is odd, it must have, and this actually relates more to that theorem than this one down here, at least one real root. Why is that? Well, if you think about it, an odd function has opposite tails. Well, if this extends to negative infinity and that extends to positive infinity, it has to cross the x-axis at least one time. So that's why an odd function must have at least one real root. An even function, not necessarily. Here are my axes. Here's an even function. Never crosses. Okay, let's do a couple quick examples here. For the following, list the possible integer roots, find the roots, sketch the graph. This is where it starts to get interesting. So first thing I'm going to do is list possible roots. So here's how I like to start. Plus or minus. And then I list all the numbers that are factors of my constant term. There's my constant term 4. So all the factors of 4 would go in here. Okay, well, that's simple. 1, 2, and 4. That's it. So now, how do I find the roots? Well, guess what? Trial and error. You guys start guessing. You could guess 4. You could guess -1, 2, -4, +1. So we have all sorts of numbers to guess. It's going to be trial and error. You're not going to get it right on the first try. All right, so there are some shortcuts that you can predict, but I'm not going to start that. My recommendation, I usually start with the smaller numbers just because the synthetic division goes a little quicker. So I'm just going to start with a 1. I don't know if it's going to work or not. We're just going to try it. So I'll try 1. What are my coefficients that are going inside synthetic division? A 1, -4, -1, and 4. 1, -4, -1, and 4. Bring down, multiply, add, multiply, add, multiply, add. I lucked out. So what do I know? It says find the roots. I just found one root. One root is x equals 1. Write it down, circle it so you don't forget. Remember, this right here is a possible root. If it works in synthetic division, gives me a 0, then it is. If it doesn't, and I get some value here like, -7, then no, that's not the root. But this one worked, so I'm going to circle it. Now, what do I have? I've got a depressed polynomial. I'm not going to do synthetic division again because I started with a cubic. I depressed it 1 degree. Now it's a quadratic. It's x squared minus 3x minus 4. So I'm just going to write that out and factor it. X squared minus 3x minus 4. Okay, I'm going to set it equal to 0. Let's factor this. It's going to be x minus 4, x plus 1 equals 0. So my other two roots are going to be x equals 4 and -1. So here are all my roots. Find the roots, and then it says sketch the graph. All right, I don't have a ton of room to do this, but here's how we're going to sketch the graph. My roots are 1, -1, and 4. So -1, 1, and 4. I need a y-intercept. My y-intercept is going to be y equals, it's pretty easy. It's right there. All right, remember the y-intercept is what you get when you set x equal to 0. So this is a 0, that's a 0, that's a 0. What's left? That 4. Y equals 4. So let's put a mark up here, call that 4. It's got to go through those. What do you know about your tails? Tails, I notice it's an odd and it's positive. Positive odd. So it's going to look like this. All right, so now I need to sketch it through. I don't have any double roots. I don't have any triple roots, so it's going to pass through every time. There you go. All right, let's try this one over here. I'm going to list my possible roots. Plus or minus all the factors of 12. Well, we got more of them now. So it could be plus or minus 1, 2, 3, 4, 6, 12. All right, this is where it gets interesting. What are we going to guess? Well, I tried a 1 over here and it worked. I could try 1 again. I'm going to mix it up a little bit. Let's try -1. Coefficients, 1x cubed, a -8x squared, 19x, and a -12. Bring down, multiply, add, multiply, add. Multiply. That's not going to work, right? That's not going to give me a 0. I need a 0 here. Okay, scrap that. Didn't work. It's not always going to work on the first try. I don't know. Let's try a 2. I got a 1, a -8, a 19, -12. Bring down, multiply, add, multiply, add. Oof, close, but no cigar. So, scrap that one. Well, let's try 3. I got an idea that 3 is going to work. 1, -8, 19, -12. Bring down, multiply, add, multiply, add, multiply. Got it. All right, so what do I know? X equals 3 is a root. I'm left with a depressed poly of x squared minus 5x plus 4. Let's factor that. That's going to give me x minus 4, x minus 1. So I got 2 additional roots of x equals 4 and 1. To continue sketching, I need a y-intercept. Y equals, remember it's pretty easy, it's right there, -12. Tails, what do we have? We have another positive odd, so it's going to look like that. So 1, 2, 3, 4. I've got 1 and 3 and 4. My y-intercept is a -12. So what I'm going to do is I'm just going to put a mark down here at -12. And I know it's got to go through those points. My tails are heading down, and that one's heading up. So basically, it's just going to go like this. And there's a tiny sketch, but you guys get the idea. And this is what we're kind of gearing up towards. I'm going to give you a polynomial, and I'm going to ask you to sketch it. And it's going to be a 4th degree, a 5th degree, a 6th degree, and you have to list all the possible roots, do trial and error to rule some out. Once you start getting roots, we get depressed polynomials, and then we keep going. So these were easy because they start out as cubics. But if I give you a 6th degree, once you find one root, then it gives you a 5th degree. So then you have to guess again. And then you have to guess again and again until you get it down to a quadratic. And that's what's kind of cool about these problems is you keep using synthetic division, but you narrow it down each time by 1 degree. So I'm going to stop here for day 7. We're going to continue with day 8 with more of the same. We're going to add another theorem, but you should have more than enough now to do the homework 7. If you have any questions, as usual, reach out. Thanks for watching, guys, and we'll see you in school soon.